So in today's lesson, we're going to be discussing how to calculate the volumes of pyramids and of cones. So before we begin, I want to do a quick revision of some of the basic names of certain three-dimensional shapes that we're going to be calculating the volume of, because a key strategy in knowing which formula to choose to calculate the volume is knowing what shape you're looking at, knowing how to identify it. So what I'd like you to do is pause the video right now and discuss amongst yourselves what you think the name of some of these three-dimensional shapes are, okay? What the names are. So let's do that now. Okay, so hopefully you've had the opportunity to discuss the names, and let's see how you did. So when I look at this first shape here, the yellow one on the upper left, I can see that it has a base that is a square. And so because the base is the square and all of the faces are a perfect square, I can say that that is, with great confidence, that's a cube. So I'm going to write that in. Now, if you guessed that it was a rectangular prism, then that's actually also correct, because a cube is just a specialized type of rectangular prism where all of the faces are of the same dimension, same length and width. Okay, moving on down. So when I look at this, I can tell first of all that it is a prism and not a pyramid. So I'm going to compare these two shapes here and discuss the differences. So what makes this shape on the left a prism and not a pyramid is that it has sides that are parallel to each other and they don't meet at a point. Whereas my pyramid has sides that are never parallel, and I can tell that because they do meet at a point. So definitely this is a prism and definitely this is a pyramid. Now, I can further distinguish between what type of prism and pyramids they are based on the base that each of them have. This prism right here has a base that is a triangle, and so I can safely call this a triangular prism. Whereas this pyramid has a base that is a triangle. So not only is it just a plain old pyramid, it's a triangular pyramid. Okay, I don't want to forget about this figure up here on the top right. I think you can recognize that it's a three-dimensional circle. And what do we call a three-dimensional circle? We call that a sphere. So some important properties about spheres are that, in the same way that we would, if we were looking at a plain old circle, we can talk about the distance from the center to any outside point. And we can call that the radius of that circle. And if we were to look at the whole distance moving through the center of that sphere, that would also be considered a diameter. So that's important to think about. All right, I'm going to compare this particular figure here with the one right below it. So I can tell that this figure right here is definitely a pyramid, and the one below it is a prism, because the prism will have parallel sides that are parallel and never meet, whereas the pyramid meets at a point. So yeah, definitely I know that. Now I need to look at the base of each of them to decide what kind of pyramid or prism it is. And since this pyramid has a rectangular base, I don't know if it's a square base, but I'm going to assume it's definitely rectangular. I'm going to call it a rectangular pyramid. And this one on the bottom, rectangular prism. Let's get some of this down.
Vandenberg call extension 300, please? Ms. Vandenberg?
Okay, so next let me compare this object right here. Well, some of you probably guessed that it's a cylinder, and what probably told you it was a cylinder is that it has a circular base. And it's not a cone, because a cone does not have the parallel sides. We see that the sides meet at a point, and that gives it that nice cone shape. So the difference between a cylinder and a cone is that a cylinder has these sides that are parallel and never meet at a point, and the cone does.
Davis, phone call line 1. This is Davis, phone call line 1.
All right, so now I want to talk to you about the relationship between a few of these. Namely, I want to show you the relationship between a cylinder and a cone, and also a rectangular prism and a rectangular pyramid, so pyramids and cones. And those will be the focus of our discussion today. Now, as I've mentioned last semester in our GLS course, you can calculate the volume of any prism or cylinder as long as you, or any figure for that matter, that has sides that are parallel and don't meet at a point, if you know the area of the base. So for instance, in the case of this rectangular prism, I know the base is a rectangle. In the case of my triangular prism, I know the base is a triangle. And in the case of my cylinder, I know the base is a circle. And I'm going to use that information to help me find the volume without knowing any specific formula for the volumes, although you can always find those on your formula sheet. So the volume is always equal to the area of the base. And I'm going to use a capital B to mean the area of the base times the height. Okay, so I'm not talking about the base of a triangle. I'm talking about the base of the entire prism itself. So, well, how do I calculate the base of a rectangle? Well, the base is a rectangle. How do I find the area of that base? Well, it's length times width times height. And so there's a condensed formula for, that's where we get the formula for the volume of a rectangular prism. All right, so moving on in the same way, when I look at this triangular prism over here, I know that the volume is going to be equal to the area of my base, so capital B times the height of the object. So, well, what is the base? It's a triangle. And you may remember that the formula for a triangle is base times height divided by 2. So the area of my base times the height. But what is the base? It's a triangle. And so I'm going to replace this big B right here with the formula for a triangle, which is the base of the triangle itself. So if this is the base that I'm talking about, times the height of the base itself. So that's this dimension right here, divided by 2, times the height, and that's this height that I'm talking about, of the actual prism itself. Okay, so notice the difference here between the height of my triangle base versus the height of the actual prism itself. And so that, I know that's a little tricky. We'll do a couple of examples that will help you to figure that out in a little bit. So moving on. So when I look at my cylinder here, I'm going to use the same basic formula to find volume of a prism. So the volume is going to be equal to the area of my base times the height. So in this case, the base happens to be a circle, and the height again is just the height of the prism itself. Okay, so since the base is a circle, well, what is the formula for the area of a circle? Well, it's pi r squared. So that doesn't change. Pi r squared. And now I multiply by the height of the entire prism. And so there's a nice, that's where the formula that for the volume of a cylinder comes from. It comes from knowing what the area of the base is. So hopefully that will help you remember some of the details of how to calculate the volume of prisms and where those volume formulas come from. All right, so when we look at this particular figure, I can tell that it's a triangular prism. And so I'm going to remember that its volume is going to be equal to the area of its base times the height of the figure itself. And maybe we'll make that capitalized so that we can distinguish between help us decide which height we're talking about. So, well, what is my base in this case? Well, the base happens to be this triangle right here. And so we need to calculate its area first so that we know what our capital B is. So here it is, and when I focus in on this figure right here, I see that it's a triangle, and the area of my base, the area of that triangle, is going to be the base of the triangle times the height of that triangle base divided by 2. And then at the end of that, I'm going to multiply by the height of the entire figure. So, well, what is the base of this triangle? Well, the base is this 8 centimeters right here. It's the bottom part. So I'm going to replace little b with 8. So what is the height of that base? Well, the height of the base is this 3 centimeters, not here. It's not the 12 centimeters because that's the height of the actual prism. The height of my base is 3 centimeters. So I'm going to put that in and replace my little h with it. And I'm going to divide that by 2. Now I'm going to take a look at, well, what is my big H? What is the height of the entire figure? Well, that's that 12 centimeters, this length right here. So I'm going to substitute that in for capital H. So times 12. And now I'm ready to do my multiplication to get the final volume of the entire figure. So working this out, I know that 12 divided by 2 is 6. 6 times 3 happens to be 18. And then 18 times 8, that's something you may want to work out on your calculator. This is me running to my calculator just to be double sure. And that gives me 144 centimeters cubed. Now remember, I'm taking centimeters here and multiplying them by centimeters and by centimeters. Centimeters times centimeters times centimeters, and that's where I get my cubic units from. I'm going to double check that calculation just to make sure. So 8 times 3 times 12 divided by 2 gives me 144 cubic centimeters. Hopefully that example will help you to perform some of the questions in your workbook. So in your workbook right now, what I'd like you to do is open up to page 32, and I would like you to try question number 1. You should be able to do question 1 with a lot of ease, and when all of you have successfully completed question number 1, then we'll do an example for question number 2. So pause the video now, complete question number 1 on page 32, and next I'll do an example that will help you with question number 2.